Greetings, this is Artie from Artifact Electronics, and we're looking at a 19-inch black and white vector monitor here. Now originally I was not going to do a video on this, and that's why I've already done some work on it, because I've done them before and there's only so many monitor repairs I am guessing my audience would like to look at. But I found something really interesting during the repair of this, and I think it would be beneficial to most of my audience to watch this, because it turns out to be a bit of a cautionary tale. So let's dig in. This monitor came out of an Atari Asteroids upright cabinet. I saw an ad for it about a week ago, and it was suspiciously cheap. Basically, for the price of a working Asteroids PCB, I got a whole machine, and the ad said needs some love. So sure, why not? I drove out there, I saw the machine. It looked kind of nice on the outside, and we made a deal. The seller insisted, though. He said, I want to demonstrate, because before I put this away, you could still play this blind. And what that means is you coin it up, you know, the lights are blinking on the control panel, you can start a game, and you can hear the game sounds, which I am intimately familiar with by this point. And that way, you know, show you that the only thing that's wrong with this is the monitor. I said fine. We pulled the machine away from the wall. I was in his garage, and he goes to get an extension cord, at which point I realized that the power cord, not to this, but to the whole machine, had been cut off clean at where it entered the cabinet. And I'm sure that contained a lot of relevant information, which I didn't know how to interpret at that point. Anyway, I told him not to worry about it, because I was going to buy the game 4 parts. I checked it out. All the boards were in there. The only strange thing was the monitor, because the monitor boards, the deflection board, the high voltage board, the high voltage cage, everything was kind of lying in the back of the monitor. Everything was unplugged, of course. And these transistors you see over there, 3 of them were unplugged, and they were like in a bag along with the other stuff. So of course I secured all the stuff, took it out, put it in the coin box, and brought everything home. And the idea is that the monitor, instead of me having to go and toil in the garage, I was just going to attack the monitor first, see what was wrong with it, and I can test it on my Asteroids cocktail, which is really easy because it's just around the corner from here, and they're fully compatible, the monitors that are compatible, except that this one's bigger than the one in the cocktail. So I needed to reassemble the puzzle, because the monitor was in pieces. And as I mentioned before, some of this work has already been done at a point where I had no intention of filming this. But I ran into something interesting, and my intentions intensified to share this with all of you. First off, we are dealing with high voltages in the kilovolts in here. So be neither an idiot nor fearless, and don't do this unless you know exactly what you're doing. I'm doing this to show you what went on, and this is not a ticket for anybody to go out and say, oh, it looked so easy the way you did it, I think I'm going to attempt to do this myself. Don't. There's many ways you can hurt yourself in one of these things. So unless you know exactly what you're doing, just take this video at its entertainment value. So as I said before, I had done some work on it before. The three of these transistors were removed and lying in there along with their insulators and screws. The sockets are behind. I tested the 3 transistors, and this transistor was shorted. No big deal. I have a few extras. I replaced it, put new transfer paste on there, put the insulators in there, and reattached these 3 to their respective sockets, which have connectors that plug into the deflection board. Then I took this one out, tested it, and this one was good, so it went back in. Notice also that I've marked them. That's not a factory marking, that's me, because it's really easy to make a mistake and put the wrong transistor into the wrong place. So it's usually a good idea, when of course the transistors are still in there, to actually mark down on the case which is which. And I'm kind of surprised they didn't stamp the case with those, because I can imagine people putting the wrong transistors in the wrong place and starting a wild goose chase. Oh, and by the way, this is a Wells Gardner model number 19V2000, which was used in earlier revisions of Asteroids, and I think also Gravitar or Lunar Lander. Eventually this monitor, Atari dropped this monitor and went over to Electro-Home monitors because it had a pretty high failure rate. But back to this transistor, so I took it out, it was good, and as I was putting it back in, I noticed that the insulator, the top part of the insulator here, was missing completely. And that isn't good, because what that means is once you screw this thing in, you're shorting the collector, which is the case of the transistor, to the case of the monitor, which is ground. So that would have caused a lot of problems right there. And that was the only transistor that was still mounted. So draw your own conclusions from that. I think we're getting closer and closer to the reason of why they just got sick and tired of it, cut the power cord off to maybe limit their liability, or maybe they had a conscience, but before selling the machine they basically said, we're going to cut off the power cord so nobody can just go and plug this thing in. Alright, so we took care of the deflection power transistors. Then we look at the deflection board itself, and it pretty much looked like this, except there was a power resistor mounted here, and this power resistor was missing completely. And to illustrate what that would cause is, so this is the input section here. And we can see, both legs of the AC coming in are fused, going into the bridge, and then when it comes out, the DC side has these 3.9 ohm, 15 watt resistors. So obviously with one of them missing, you're only getting like 3/4 of the voltage required, and that can cause a few interesting things to happen, but the monitor should still come up, which was the case here, of course. But when I measured the one resistor that was still in there, it was open. So there was no power flowing to the deflection board at all, and thus it couldn't work. Because that power supply I just showed you, that's all the voltages for the monitor are derived from that input. It has an AC input, and through this, and that AC is basically regulated to all the required voltages. What I did, and I do this on pretty much whenever I find these power resistors shorted, I basically strap a short in place of the power resistors. And the reason I do that is, looking at the schematic, these resistors are here, and their sole purpose, well, their primary purpose is to limit the inrush current you get when you're applying power for the first time and the big filter caps are discharged. You're getting quite an inrush of current over here, and I think this was put in there to limit that inrush and kind of save the capacitors and not have too much current flowing. And these resistors do commonly fail, even though they're 15 watts. So a better thing to do is basically short them, take them out, and commonly what you do is, if the resistors are still good, leave them in there, but if they're starting to drift in value or they're bad, take them out, always in pairs. Don't leave one resistor in and put a short on the other side, leave things balanced. But that's the reasoning behind me using heavy gauge wire to short that and make sure that we're getting power, that the main power source is coming in. Other than that, I reflowed some of the connections on these connectors from underneath, which usually gets stressed when you're plugging stuff into there. And I measured capacitors. And yes, there's going to be a group of people who say you should, regardless of what else you do, you should replace the capacitors. This is, at this point, this is still a repair video. When you're restoring everything and you're making it bulletproof for the next 25 years, yes, all the capacitors need to go. But at this point, I'm going to do whatever's required to repair this. Thus, I'm not changing the capacitors right now. They will be replaced down the road, but not now. So I checked everything on here. I can't really test this yet, but after having done some tests, general tests for shorts, capacitors being bad, I tested the capacitors in circuit, and they all were they were all in ballpark values. Also, the bridge, should always test the bridge for shorts. And you know, that's basically 4 diodes you can test as 4 individual diodes, and all of that was good. So for now, we're done with the deflection board. Next, we have the high voltage board, that, because it's supposed to generate something like 15 kilovolts DC for the anode on the CRT. Sits in a cage like this, which also doubles as a heatsink for some driver transistors. And here's the cover. And from the way I remember it, this cover was supposed to be one piece. It has, or had, at one point in time, the second piece of it. It was basically one piece bent at a 90-degree angle like this over here, but this was broken apart. Because normally only this piece screws into the metal frame, and that's what holds this into place. This doesn't have, there's no screw holes to hold this, so this is incorrect. I mean, somebody got frustrated, or I don't know, somebody broke this apart. What does that mean? I don't know, but there are some, can you see that? Can't, of course, not see it very well, but oh yes, there you go. There's some burn marks on here, and they are right next to this power resistor, because this part goes here. This resistor is good. It's the first thing I tested. But the way I got this, remember I already worked on this. So, you know, here's the high voltage cup. Here's the output from the flyback transformer, which really isn't a flyback transformer on a vector monitor, because there's no flyback, but that's the nomenclature most people use, and I shall do the same thing. And what we're looking at here, this is the output of the transformer, and what's missing, this needs to be connected to this with a high voltage rectifying diode. And those diodes are getting, I mean, you can get them, as a matter of fact, Arcade Shop carries them now. But what we're looking at, to illustrate the point here, this is what it looks like. This is the flyback. This is the vertical driver transistor. And we have one secondary that is grounded on one end. And what happens here is voltage comes out, gets rectified by D903, and then this goes to the CRT. So this is the red wire over here, and this is the black wire coming out of the transformer. And as you can see, there's a rectifying diode here. We have about 20 kilovolts coming out here AC, and we have a half-wave rectifier, and we have a capacitor here. What capacitor, you say? Well, the CRT tube, of course. That's the capacitor. So with a half-wave rectifier from 20 kilovolts AC, we'll get approximately 15 kilovolts DC, and that's pretty much what they specify the voltage should be set to. So in this case, I had this here. There was this glob with things in it, And I started removing that glob. There was, I think this is like silicone glue. So this was like underneath it, this big piece. I scraped it off, and lots of more bits and pieces you can see in here, and lots of stuff that fell under the desk that isn't even here, but there was this big glob of this glue on here and this, and I looked at it and I'm like, yeah, okay, you know, it's not that difficult to find these diodes because there are subs made by NTE and SK, but hey, you know, maybe somebody found a way to do this cheaper. And I kind of looked at this, and it turns out that this is probably the main reason why they cut off the power cord to the unit. What did I do? Once I had fixed the deflection board, I put the whole thing back together again, and I went and I hooked it up to my Asteroids cocktail. Yeah, I did that. So I turned it on, and I mean, this thing was arcing like there is no tomorrow. Even with all this glue that was all over, and especially with the red part connected to the diode, I suppose, over here, this was completely encased in silicone glue or whatever that stuff is. But I guess even with all of that, the dielectric strength of the glue was not enough to prevent arcing. Yeah, it arced pretty good. I turned it off real quick because it was not just bright, but it was really loud too. And that's the reason why they cut the power cord off, because they, you know, they didn't want anybody to plug it in, I guess, and have the thing go up in a burst of smoke. But I looked at this thing with magnifiers and stuff like that, and it kind of looked vaguely familiar to me, but I couldn't figure out what it was. And then finally I did a web search, and then it all came back to me. So what this is, it's a voltage doubler. And we saw this before when in a previous episode I repaired an Atari 1050 floppy drive, which in the power supply had a voltage doubler. And the way that looks is, here's what I found. So you're coming in from the flyback, you go through a cap, then you have one diode with the cathode on this side going, supplying to the high voltage on the CRT, and then you got another diode here with the cathode going up connected to ground. And yes, this is a voltage doubling circuit, so whatever AC you put in gets close to being doubled coming out the other end, because, and I won't get into that, there's many things on the web explaining that, but that's what it was. So my original thought was, well, wait a minute, they put a doubling circuit in here. And these specs say that there's about 20 kilovolts coming out of here. So if you take out this diode and you put a voltage doubler in here, you're going to get somewhere around 35 kilovolts being delivered to the CRT. And that's why this thing was arcing that badly over here at where it connects to the red wire, because at 35 kilovolts, I guess you need a lot more than half an inch of silicone glue to properly insulate it. And I guess once they saw that, they wrote off the machine. Now, the big mystery was why. I've seen some really dumb things being done on repairs, and I understand that people working for operators are pushed for time, get it working right now, I'm not making any money on it, but this is actually criminal to do something like that. But was somebody that malicious, or was somebody that stupid? So the mystery, I finally solved the mystery, and this mod, it turns out that another kind of monitor, and if you look closely at this, at the picture of the HV cage, the way the flyback is pointing, the way the components are on it, let's see, where's the connector? The connector is, I'm trying to figure out if I got this oriented right. This goes like this, So the red wire comes out of this side. So this is how we should look at it. Now, if you look at this picture and this board, they don't look anything alike. This is a different board than this. And then I finally read the whole article, and it turns out that a different monitor that was used in Atari Asteroids actually had a flyback transformer that had a lower output voltage, and from the factory it came with a voltage doubler at this spot here. And that was perfectly normal because I guess, that was only outputting, I don't know, 15 kilovolts. And that with the voltage doubler, they got up to the required 15 kilovolts DC. So here's the story then. The voltage doubler is pretty much non-obtainium. Couldn't get it. And so somebody surfed the web and they found this. And they went, that's fantastic. Here's a way to replace that diode and get this thing up and running again. Except they put it on the wrong PCB. So to sum it all up, some idiot messed up big time and put a voltage doubler on something that shouldn't have a voltage doubler. That's why the power cord was cut off, and that's why it was arcing like crazy. So looking at this a little closer, you can clearly see this was where the flyback fed. This is the first diode. It's kind of like this, I guess. This fed into a ground connection. No, wait a minute. That's not right. Oh, the other way around. Here's the capacitor. The capacitor was fed from the flyback. Then it came to the junction where one of the diodes was grounded on the board through here and was connected to the actual, and this is where the high voltage came out that this was connected to. That's how it was, and it arced right here, real good. So there you go. What do we learn from this? If you see some sort of a weird looking modification, don't plug it in. Either figure out what that modification is, or take lots of pictures if you don't want to spend the time, and remove the modification in its entirety and put it back to original. You can get the diodes. I mean, I think I mentioned Arcade Shop carries them, and there are NTE parts that do it. They're not that easy to come by anymore because I don't think NTE makes them anymore, but there's still lots of them around, and if you look close enough, you can find them on eBay. Or, as I said, you can just buy them from Arcade Shop. And that's pretty much where I'm at now. I've ordered some of these diodes because I found an eBay seller that actually had NTE parts, but the diodes aren't here yet. And I guess we're going to have to wait till the postman shows up, and then we can see, is it as simple as putting in that diode over here. I mean, it's a pretty long diode. It's about this long. It's a little longer than this resistor, actually. And it has these cups at either end that have a bunch of grease on it, dielectric grease to not make it arc. So nothing I can do because I know that at one point in time I actually had one of these diodes, but of course I can't find it now because the last time I saw it, I was a lot younger, so it was a long time ago. So we're just going to have to wait till the new diode shows up. And then, of course, the risk is, I'm not that familiar with the resiliency of CRT tubes, but since we gave it probably more than twice the voltage that it actually wants, I don't know if that took out something in the CRT, or if it just bathed me with gamma rays, and that is my punishment for being stupid. But let's wait till the diode arrives, and then we can see if we can repair this thing. Here's what I got in the mail today. And that should let us continue on our quest to get the monitor working again. It's the diode we need. You can see it's rated at 35 kilovolts. Here's the NTE number and here's the SK crossref number, and this is what it looks like. Note the date code. This thing's 33 years old. Good thing it's not a capacitor. So let's install it and see what happens. So I installed the diode, and what I did was the ends need to be insulated, obviously, so it doesn't arc, even though the possibility of it arcing at 15 kV versus 35 kV are a lot less. But I put 3 layers of shrink wrap at the ends. Well, I cut the terminals, the legs of the diode, really short, soldered it directly to the respective wires, and then shrink wrapped it 3 times while putting some dielectric grease in between layers of shrink wrap, and that should probably be sufficient to keep it properly insulated and prevent arcing. And I held things in place with a little bit of hot glue because the tops of the post had clips to hold these, but they were severely mangled. So with this setup, it is safely mounted over here, and things should be safely insulated. But let me put the whole thing back together again, and we can do our big test. Alright, I put it all back together, hooked it up to the cocktail. There's a cage. I left the cage cover off, so what I'm going to do is turn the lights off to see if there's any coronas. And so here goes. Let's turn this light off. And I'm turning on power. Okay. Come on, baby. Oh, I can see something, and we got liftoff. What do you say to that? It works. It works, and to do the corona test, I'm going to turn off even more lights. And yes, I'm pointing straight at the high voltage cage. Nothing's arcing, so my insulation is good. And I'm going to let this thing run for a few hours. And if we look at the HV voltage, well, the high voltage, we are at 14.6 kilovolts. 14.5 is nominal, and that's holding. It'll probably go up a little bit as time goes on, but yeah, there you have it. Another monitor fixed. So I think what we can learn from all of this is if you see some weird modifications and stuff you're fixing, take out the modification. I mean, you don't even have to figure out what it is. Just take it out and bring it back to standard. This was quite ridiculous. Anyway, thanks for hanging out. Make sure to raise your thumb and to subscribe. And leave me a comment. Let me know about what kind of weird modifications you've seen. Anything that comes close to this being as lethal as this could have potentially been. See you next time. And I should add, I replaced all the capacitors that I had in stock on this, but it still needs the main filter caps on the deflection board. There's a bit of flicker on everything, which the camera kinda hides, But, you know, that's standard stuff. I go out, I get the caps, I replace them, and then we're ready to go on to the next one. See ya.